Welcome to our presentation on luminance-dependent uniformity in OLED displays. My name is Andreas Liebel and I am Product Manager at Instrument Systems. Before we start with the presentation, just a few words on our company. Instrument Systems is a German company working on the development, the production and the sales of light and display measurement devices with high accuracy. Main application fields are all kind of display testing, AR, VR, VCSEL testing, automotive applications and many more. Our headquarters is in Munich, Germany, and we have also sites in Berlin and Korea. And besides that, of course, a lot of sales and service partners distributed all around the world. Today's topic is the uniformity of OLED displays at low luminance. OLED displays have in principle the potential to give infinite contrast due to their emittive nature. However, if we talk about dark ambient conditions, there are restrictions. The devices are then typically operated in the range of about 20 candela per square meter. And in order to maintain a high contrast at these conditions, it's required to have a stable luminance also down to values in the range of 10 to minus 2 candela per square meter. So in order to assure a high quality control of OLED displays, we need to assure that we can measure the luminance and luminance uniformity at these conditions. This is an example of a spatial luminance non-uniformity which was measured with our LumiTop 4000 device in the range of 10 to minus 3 to 10 to minus 1 candela per square meter. And this would be visible by human eye, and of course it has to be calibrated in order to get a high quality display in the end. Another example is this one, which shows the uniformity on pixel level, which was measured with our LumiTop X150 device. And this device has a resolution of 150 megapixel and enables single pixel evaluation even for larger DUTs. You can see that for decreasing gray levels, the individual pixels start to be brighter or less bright than the others. So there's really a non-uniformity in luminance and will also lead to false colors. So there's really the need to calibrate, and with these measurements you are able to calibrate this on pixel level. The spectrally corrected imaging colorimeters LumiTop have the following working principle. The principle is based on an RGB camera combined with a spectroradiometer. It's a simultaneous measurement, which means both devices are operated and measured at the same time. The RGB values are transformed into the XYZ color space, and the spectral data from the spectroradiometer is used for fine correction of these values in order to get the best possible color accuracy. Since this is a simultaneous measurement, it's really a one-shot solution, and it's therefore a fast measurement which enables to be used in production quality control. The system always comes with the LumiSuite software, which comes with a user-friendly graphical user interface and an industry-proven development kit SDK. The acquired images can be pre-processed and analyzed with the different tools available. Let's have a look at some low luminance measurements which we performed on different OLEDs. The measurements were performed with one of our newest LumiTop X series devices in the range of 10 to 3 down to 10 to minus 3 candela per square meter. The maximum exposure time was 5 seconds, and there were 30 images acquired, each with a 5x7 grid of spot meters. Additionally, we also did some reference measurements with a stable OLED light source at around 5 millicandela per square meter in order to determine the instrumental precision. So how do we get a stable OLED light source for low luminance? You cannot just go ahead and dim down the display, because as you can see, for low values like here 20 millicandela per square meter, you can see that for the individual measurements there's a lot of change in luminance which you measure. But what can you do? You can use an OLED at higher luminance, around 400 candela per square meter, for example, and use an ND filter in between in order to dim down to the low values of around 20 candela per square meter. And in this case, you can see that you have a nice stable light source which still has the spectral characteristics of an OLED. The instrumental precision which we measured with these kind of light source is very good. Also for low values like this here, 6 millicandela per square meter. So you can see that the luminance values over the different measurements are really stable, and also the uniformity over the display is very nice. You have a mean uniformity of 70.8 in this example, and the instrumental precision is better than 0.2%. So we have a very good instrumental precision even at low luminance, and this is the prerequisite to enable measurements on OLED displays at low luminance. So these are measurements which we performed on some real devices. 5 different phones were used, and on each we applied again a 5x7 grid of spot meters. And as you can see, the luminance which is measured over the different gray values follows a very nice linear trend down to a value of gray value of about 8, which corresponds to approximately a few hundred millicandela per square meter. And below that point you can see that there's a large spread between the different phones. And the same accounts also for the measured uniformity. We start at very nice values around 90% uniformity, going then slightly down with great value. And again at a certain point you can see that there's a drop in the uniformity. So this really shows that we have to measure the luminance and luminance uniformity in this range in order to correct for it. So we have said that OLED technology requires calibration to very low luminance in order to take advantage of the potentially infinite contrast. However, we have seen that current state-of-the-art devices appear to have decreased contrast and uniformity in the range of low luminance at very dark ambient conditions. You can imagine that this is even more critical for larger display sizes because they tend to be less uniform at low luminance. So there's really the need for light measurement devices which are able to assure high stability and high accuracy also at low luminance in order to perform precise measurements under these conditions. With this, I would like to thank you very much for your attention, and if there are any questions, please feel free to contact us anytime. Thank you very much.